Hello everybody, thanks for tuning in to this video. I have 10,000 subscribers here on my FreeCAD Academy channel, which is absolutely incredible. So therefore, it's super nice to see this great support. I decided to give something back to you, and for this video I teamed up with Brad Collette, who you might know under his name Sliptonic. He is not only the author of FreeCAD books and an expert in the field of manufacturing, a field where I am definitely not an expert. And we decided to make two videos. Brad made one video, I make one video about the product design process from the first prototype to the complete manufactured part. We will start in this video here, showing you how to design the first prototype in every single detailed step. Go to the next step, develop the second prototype where you see some of the geometry has dramatically changed. How do you make these changes in FreeCAD without destroying your whole part? And for the next video in the series, you have to switch over to Brad's channel and watch the video on how to manufacture the part. So I wish you a lot of fun with this video. Let's go. I will now show you the modeling process in every detailed step, which can be a great exercise for learning FreeCAD and the FreeCAD part design workbench. So we start with a new file, clicking on File, New. So please make sure that we are here in the part design workbench, and we click on the combo view in the Tasks tab, create a new body, and under the new body we create a new sketch by clicking on Create Sketch. We select as a sketching plane the XY plane here, go to OK, and then we are in the Sketcher workbench. So let's start with the basic geometry of the grind plate. We will start with a rectangle. We click on the horizontal axis here and click here to make it complete. Right click. The next thing we need to do is to delete this edge here. So select it, click on delete on the keyboard. The next thing we need to do is to give some basic dimensions. We click on the horizontal distance button, the upper edge here, and click 142 millimeters. Then we click on the vertical distance on this edge here, and we define 25 millimeters. The next thing we want to do is we want to make this geometry symmetric to this green vertical axis. Therefore, we select the upper corners here, the vertical axis, and click on symmetric. Now the last thing we need to do is to define where this point is located. We just glue it on the horizontal axis by clicking the fix a point onto an object command. So now we have a fully defined geometry and can continue our sketching. Next thing I want to make is to create a radius down here for the grind area. So I click on endpoints, arc, select these 2 points here and define the arc. Now we need to define where this center point of the arc is located. Just glue it on the vertical axis, center point, vertical axis, fix point onto object, and we're fine. The next thing is to define the radius. Click on radius, constrain a radius command, click this radius and define 30 millimeters. The position of the center point is not yet defined. Therefore, we click on vertical distance between the sketch origin point and the midpoint of the radius and define 26 millimeters. Then we have to close the geometry, select the line tool, and just connect these 2 points and these 2 points. And the first basic sketching is done. So we click on close, can click the pad command here. Pad is selected sketch. Look in the model tree that the sketch is selected. Click on the pad command, 6 millimeters. And as you see, we will have the first basic shape of the grind blade finished. There are two slot holes here in the grind blades that go through the whole geometry, so we can define these two slot holes also in the original sketch. So we open the pad here again, go to the first sketch and define the slot holes. Therefore, just simply create a slot in the sketch, define the slot to be located here, and the next slot here. Right. So let's make the radius of both slot holes equal to each other. Select both radius here. Go to the radius command. Do you want to share the same radius? Yes, I want. 3.5 millimeters. I need to enter comma here because it's the German edition of FreeCAD, so don't be fooled. Okay. So the next thing, let's make sure that these slot holes are in the same height. So vertically, let's align them vertically. We can easily create a line. Click on the construction geometry command. You will see that the line now is blue, and connect the two outer points of the slot holes with each other. Right click, and as you see, that happened automatically. FreeCAD set this line to be horizontal because it was only in a very slight angle, and so FreeCAD thought it would be a good idea to make this automatically. If that did not happen to you, like for instance like this, let's see, it would look like this, then you could click this construction line and set it to horizontal constraint manually. And then you need to define where the slot holes are positioned. Let's start with the vertical distance from this center point to the sketch's origin point, 12 millimeters. Let's define the width of a slot hole here, 20 millimeters. Here the same, 20 millimeters. Now let's define the length of this line here, 116 millimeters. And it's not yet symmetric. You see there is 1 degree of freedom left. So just click on this and this point here, select the vertical axis and go to symmetric. And now the sketch is complete. Let's click on close. The sketch has changed. We now have two slots in the sketch that go through the whole geometry. Next thing we need to do is to create two other slot holes that go 2.8 millimeters into the geometry to make room for the screw heads. So let's define a new sketch. XY plane. Okay. Go to the section view. And now we don't want to refer on 3D geometry. So in the model view, we can hide the pad by clicking the space bar and make our original sketch visible also by selecting it and clicking the space bar. Now we see the first sketch, but no longer the 3D geometry. We are currently in sketch 001. And in this sketch, we can simply click the command create an edge link to an external geometry and link these two arcs into the new sketch. Then we go to another slot, and slot. We know that this distance here has to be 20 millimeters. Same here. Let's set the radius equal to each other. Yes. 7.5 millimeters radius. Let's check in the tasks tab that the sketch is fully constrained. Go to close. enable the pad, hide the original sketch, and now you will see that the sketch is somewhere down here. It's on the wrong side of the geometry, so the sketch should be up here on the top. And we can achieve this easily by selecting the sketch, go to its properties, select attachment, position, and make the Z positioning here 6 millimeters. So it will change from down here 6 millimeters up here, and now is located on the upper side of the geometry. And now we can select sketch 001 and make a pocket, create a pocket 2.8 millimeters deep. Okay. And now we have these nice shape. Let's rename a few things here to make it less confusing. Sketch is now named basic, shape, and pocket I rename it as large slot. Okay, so we're pretty much finished with the design. So the next thing I want to make is to create a chamfer on this edge here. I simply select this edge, go to chamfer. And as you will see, the chamfer ends here. So we need to add these edges also to the chamfer area. Go to add and click these two edges. So we have 3 edges now, size of 2 millimeters chamfer. Okay, and now the geometry is chamfered. The next thing I want to make is to create fillets on these corners here. So select these 2 edges, fillet 4 millimeters. And the last thing, I want to fillet these edges here. Fillet 4 millimeters. And okay. So that is my first prototype. Sliptonic in his video will tell you that this operation, first creating the chamfer and then a fillet here, will create a surface that cannot be easily done with machining, and therefore we will have to change this geometry here in the next steps. So after some testing on my skate with a 3D printed prototype and after some email conversation with Sliptonic, I decided to make some changes on my first prototype, and I will show you all these changes in detail. And that's a very important and very interesting part of the video, because that's something that occurs very often when designing a product, that you have to make changes on your 3D model. This can cause some problems here and there in FreeCAD, and I will show you how to handle these problems. So let's start with the first iteration. The first thing I wanted to change is the overall height of the model. If we click on the right side here, you will see that the dimension in Z direction here is 6 millimeters, and we want to change that to 5 millimeters. That's pretty simple. We only need to change the first pad, double click on it and change the 6 millimeters to 5 millimeters, and then we change the height of the whole part. Problem is we still have the sketch for the pocket. The large slot sketch here is located still at a C value of 6 millimeters. And so we could change this manually, but we can automate this very easily by clicking on large slots and change the position here from 6 millimeter, a fixed value. We click on the formula editor here. And now we define it as the pad length. Pad length is the value of my first pad, the length. And whenever I change the length here, this will be automatically inserted in the Z value here. Let's try it. If we had 8 millimeters thickness here, you will see that the large slots placement is at 8 millimeters. So you can automate this very easily, and therefore you don't need to manually change it. Next iteration is the basic shape. I need to change the basic shape. I'll click on it and make some changes. I will change the 142 millimeters width to 150 millimeters. I will change the height of the whole part to 26 millimeters. That works pretty easily without any problems. I changed the appearance of the slots here, only 14 millimeters wide. I don't need them to be as large as they used to be. Radius is okay. The 12 millimeters here is okay. Yeah, everything looks pretty fine right now for me, but I need to change the distance. 116 here will now be 124 millimeters to make the slots sit a little bit more on the outside here. Close it. Yep, everything looks fine. The only thing that I don't like is the appearance of the large slots here. So I need to change these as well. It's the 14 millimeters distance that has to change here. You could automate this as well if you like to. So, okay, that looks pretty good. Let's delete the fillet because Sliptonic said that there is problems with manufacturing of the fillet here. So I kill it and I kill the upper fillet as well and the chamfer. Next thing I want to do is to change the shape of the groove down here. Therefore, I have to edit the basic shape. This is the only change that I have to do that could cause some problems. Let's see what happens when I do these changes. When I go to basic shape sketch, I will now delete completely the whole radius down here. This could cause some errors. Let's find it out what happens. Nothing so far. That's pretty good. I have now these 2 points down here. I will add a 18 millimeter radius here and make the transition from this edge and this edge into this radius less sharp and filleted. So this could be a little bit tricky. Let's find out what happens. We start with another radius with the endpoints here. We put it somewhere around here. Set it to 18 millimeters. And now let's create some fillets that go from the edges into my new radius. First thing, I set the center point of this new middle radius on the vertical axis here. And then I start another arc going from here to there. Something like that. And another arc. Next thing is the tangent constraint that I need to set between this edge and this radius. Also between these two radius here and here and there. And then we will have a look at our degrees of freedom, what we have to eliminate. So we have 3 degrees of freedom so far. That's pretty good. We define the distance between these 2 points in horizontal distance 50 millimeters. So we have 2 degrees of freedom left. Yeah, we could click these 2 radii and say equal. And as a last step, I set this center point below the center point of my sketch 6 millimeters. So that's the next shape appearance. We will see what happens now. I go to close and you see that the slot holes here, the larger slot holes, do something incredibly stupid. And that's because FreeCAD still in version 19 has some problems with the so-called topo naming problem, topological naming. And as you remember, I defined the large slots to be defined about these arches here. And as you see, this went terribly wrong after the major changes that I did in the underlying sketch. So when I select this sketch, you see that now no longer this, and this radius is taken from the other sketch by the linked edge command here, but it's now this radius and this radius here, and therefore the sketch looks terribly off. So first thing, I need to delete these two and have to define it myself again. So I would recommend not using this command, linked edge, to avoid these problems in the future, to make the whole construction more stable. So let's work with the construction geometry. Link these two. Set them to 12 millimeters in vertical. Now we need to define the horizontal position and the length of the construction geometry here. Therefore, we close the sketch, go in the basic shape sketch, and we will see this here. I click it and I name it XDist. You see, XDist is the new name of this dimension here. Then I close the base sketch, go to the large slot sketch again, and I use the variable from the other sketch. Therefore, I select the construction line here, go to horizontal distance, and go to the formula editor. Then I need to insert the label of my first sketch. That's basic shape. Under basic shape, we enter constraints dot xdist. That's the name that I just defined in the other sketch, 124 millimeters. Okay. And now I need to make those two symmetric to the vertical axis here. Close. Now I repaired the large slots here and made it more stable towards further changes. Whenever I change this basic shape here, I no longer work with the linked geometry of these two radius here, but I work with a more independent sketch. Now, as the last step, let's add the fillets. Then you press V and 3 on your keyboard, then you get this wireframe drawing style here. You can select these four corners easily. Select fillet 4 millimeters, V1 to make the drawing style as before, and then we could add a little chamfer on top of this here. Chamfer 1 millimeters, and we are good. So that's the second prototype, and it should be a little bit more stable than what we created as the first prototype. After watching this tutorial, you might ask yourself, what's the purpose of the just designed part? And I will show you this in a second. Here, that's me doing one of my absolute favorite sports, rollerblading, grinding on a steel rail, and especially for grinding on rough surfaces like concrete or something like that. I use a grind plate on my skate frame to protect the frame from extreme abrasion on the frame's plastic. Check out Sliptonic's video on how to manufacture the part. You should check out Sliptonic's Patreon page, where you can become a member and support him and his work with a monthly donation. So if you like to see a professional cam environment in FreeCAD, it would be very good to support Sliptonic. If you don't have Patreon, you can support him under LiberaPay Sliptonic. You find him here under his real name, Brad Collette, and you can donate here. So thank you very much for watching. Have a good time and see you next time. Goodbye.